Yeah, everyone, this is the Priyanshu Choubey. Today we will talk about the soil preparation, how the soil preparation, how to take soil sampling method, and the type of instruments we are using for a preparation method. So let's see what is the soil preparation method. So soil preparation and agriculturist or a farmer should first know the properties of a soil before going to crop production so that we could understand and use thought to fundamental principles including the cultivation texture, structure, biological life, inorganic elements, inorganic elements, nitrogen, phosphorus, potassium, trace elements, organic fertilizer in the soil. So these are fundamental practices before sowing. Uh, which is for agriculturist or farmer done. Soil preparation implements like this soil preparation implements like a plow, digger, soil environment crop growth is influenced by aerial and soil environment. Suitable environment is necessary for better germination, growth, and yield of crops. Area environment is less amenable for modification. However, by adjusting plant population and weed control and the competition for light can be reduced. Soil environment can be alerted substantially by delayed fertilizer application and irrigation, facilitating free irrigation, reducing mechanical resistance, and providing adequate nutrient and water. So soil environment can be studied under a physical, chemical, and biological environment. The favorable physical environment for a proper crop growth is base soil without hard layers or high water table so that a crop can exploit a larger soil volume. The soil has to contain a higher water holding capacity, proper irrigation, and less soil strength or a mechanical resistance. The favorable soil chemical environment is a higher nutrient availability. The biological environment consists of a favorable organism in the soil. So, understanding of a soil properties is essential for its management for higher productivity. Physical environment. Soil physical environment is controlled by a soil characters. like structure, radiation, water mechanical resistance, and deep depth of soil. Soil texture. Soil texture refers to the relatively percentage of sand, silt, and clay in a soil. It is the relative percentage by weight of the sea soil separates uh, that sand, silt, and clay, or simply refers to the size of soil particles or size the distribution of soil particles. Sand usually consists of pods but may also contain fragments of feldspar, mica, and occasionally heavy minerals that Zircon, Soromylines, and hornblende has a uniform dimensions can be represented as spherical, not necessarily smooth, and has a just surface. The sand group included all soil in which the sand separated makes up at least 70%, and the clay separates 15% or less of the material by a weight. The properties of such soils are therefore characteristics. Those of sand is in contrast or to the thicker nature of clay. So specific structure classes are recognized in this group, sandy and loamy sand, although in practices two subclasses are also used, loamy fine sandy and loamy very fine uh, sand. So here is a sand picture. Since particle size intermediate between a sand and clay, since the size is similar and surface area is more. Coated with clay has the physiochemical properties as that of a clay to a limited extent. Sand and clay form the skeleton. The self-proof includes soil with at least 80% silt and 12% or less clay. Naturally, the properties of this group are dominated by those of silt. Only one texture class silt is included in the group. This picture are showing us silt, clay. In this picture, clay. Clay particle size less than 2.220 mm, clay like a needle like in shape, belong to a aluminosilicate group of minerals. Sometimes a considerable concentration of fine particles which does not belong to aluminosilicate, example iron oxide and calcium carbonate. These are secondary minerals derived from primary minerals in the rock flesh of the soil. Knowledge on the texture is important. It is a guide to the value of the land use accountability, and method of soil management depends on texture. To be designated clay or soil uh, contain at least 25% of the clay and substrate, and in most uh, is not less than a 40%. In such soils, the characteristics of the clay mm, separates are distinctly dominant, and the class names are clay and sun clay. Uh, and silty. Clay, sandy clays may condense more sand than clay. Likewise, the cells content of silty clay usually exhibit clay friction. The table are showing a texture group on the basis of a percentage of sand, silt, and clay substrate. Texture group first one are texture group and second sand and clay. So first sand 80 to 100% and silt 0 to 20 and clay 0 to 20. Sandy loam 50 to 80% sand 0.50 silt and 0.20 clay. Loam 30 to 50% and 30 to 50% silt and 0.20% clay. Silt loam 0.50% sand and 50 to 100% silt and 0.20% clay. Sandy clay loam 50 to 80% sand and silt 0 to 30% and clay is 20 to 30% clay and silty clay loam 0 to 30% sand and 50 to 80% silt and clay 20 to 30% and clay loam 20 to 30 20 to 50% sand and silt 20 to 50% silt and 20 to 30% clay and sandy clay 50 to 70% sand and 0.20% silt and 30 to 50% clay. Silty clay 0.20% sand and 50 to 70% silt and 30 to 50% clay. Clay 0 to 50% sand and silt to 0 to 50% and clay 30 to 100%. So this groups are separated on the basis of percentage. The suitable of soil to a particular crop depends on texture in addition to soil depth of water, tables, salinity and alkalinity. So a particular crop can be grown on a variety of soil. The most suitable soil for this crop differ. Rice, cotton, sorghum, coriander are grown on heavy textured soil which include clay loam, silty clay and clay. Medium textured soil like loam, silt, and sandy loam are suited for most of the crops. Sandy loam and sandy clay are lightly textured soils, uh, and these are suitable for groundnuts, potatoes, tobacco, corn millets, and leguminous fodder crops. Soil texture. The primary soil particles that sand, silt, and clay are usually grouped together in the form of aggregates. The arrangement of primary particles and their aggregates into a certain defined pattern is called a soil structure. Soil structure is an important soil property uh, which influence the soil environment. So it is effect on the amount on size of pore spaces, water holding capacity, availability of plants, nutrients, and growth of microorganisms. Soil texture controls the amount of water and air present in soil. Uh, Plant roots and germinating seeds require sufficient air and oxygen for respiration. Bacteria activities also depends upon the supply of water and air in the soil. Soil condition and characteristics such as the water movement, heat transfer, aeration, and porosity are much influenced by a structure. In fact, the important physical change imposed by the farmer in the planning, cultivation, drainaging, lining, and manuring. His land are structural rather than texture. In this picture, different types of soil texture classifications are shown. First one, granular, resemble cookies crumbs and is usually less than 0.5 centimeter in diameter, commonly found in a surface horizon where the roots have been growing. Second one is a blocky, irregular blocks that are usually 1.5 to 5.0 centimeter in diameter. Third one is the prismatic vertical columns of soil that is right the number of centimeter long, usually found in the lower horizon. Columnar vertical columns of soils that have salt at the top found in soil of arid climates. Plating thin plate, thin flat plates of soil that bear horizontally, usually found in the compact soil. And single granite soil is broken into individual particles that do not stick together always occupies or lose consistency commonly found in the sandy soil. So types and description: granular rounded surface and from rounded surface but a large than a granular. So here is the soil structure. Different type of soil structures. Description here with picture. Importance of a structure. Soil structure influenced rather indirectly by the formation of an area of pores of various shapes and size. This porous and controlling factor governing water, air, and temperature in a soil. Role of a soil structure in relation to our plant growth. Soil structure influence the amount and nature of porosity. A structure controls the amount of water and air present in the soil, not only the amount of water and air depend on soil structure, but their movement and the circulations are all controlled by a soil structure. Third one is effects or delays practices. Fourth one is structure controls runoff and erosion. Native structure normally hinder free drainage, whereas like structure granular and crumbly helps in drainage. Crumbly and granular structure provides the optimum infiltration, water holding capacity, aeration, and drainage. It is also provides good habits for microorganisms and supply of nutrients. Chemical environment, the soil chemical environment is the dynamic nutrient um, transformation and its availability in soil depends on a pH, clay, minerals, cation, and anion exchange capacity. Soil pH is defined as the negative log theorem of hydrogen ions, negative um, hydrogen ions activity. The pH of a soil indicates its acidity or alkalinity. pH influence nutrient availability, soil physical condition, and plant growth. Optimum pH means for availability of a different nutrient, like the nitrogen optimum pH. If nitrogen availability in soil, so pH are 6 to 8, and if in your phosphorus availability, so optimum pH range 6.5 to 7.5. If potassium availability in soil, so pH is 6 to 7.5. If uh, in your soil sulfur availability, so optimum pH range is 6 to above 6 and above. Calcium and magnesium availability in soil, so pH are saying 7 to 8.5%, 5. And iron availability in soil, so 6 and above pH, and magnesium availability in salts of 5 to 6.5 pH range. And boron, copper, zinc availability in salts, so pH range is 5 to 7. And also molybdenum availability in soil, so pH is 7 to above. Soil reactions, preference of a crop plant, which type of cross suitable pH is like rice, suitable pH is 4 to 6, 6 and wheat 6 to 7.5, so sorghum 6 to 7.5, maize 6 to 7.5, barley 6 to 7.5, millet 5 to 6.5, oats 5 to 7.5, uh, soybean 5 to 5.5 to 7, pea 5.5 to 7, sugarcane 6 to 7.5, cotton 5 to 6.5, potato 5 to 5.5, and tea 4 to 6. So this all the pH range are showing us different types of crop activity. Biological environment, next is the biological environment. Biological environment is the composed of several organisms belonging to both plant and animal kingdom. Because of their number and activity, several changes take place which are generally harmful to the plants, while a few of them are harmful. The activity and number of soil organisms can be modified by management practices so as to provide a suitable environment for a plant growth. Soil organisms belonging to both plant kingdom, flora, and animal kingdom. So this table are showing flora and fauna kingdom. Soil organism, first one and flora, and second one is fauna. So flora again divided into two forms, macroflora and microflora. Macroflora, roots of higher plants. Macroflora and roots of higher plants, and microflora means bacteria, fungi, actinomycetes, algae. And fauna, macrofauna, earthworms, moles, ants. Microfauna, protozoa, and nematodes. Description here, bacteria usually one cell the size of 1 mm to 0.001 mm, and dies organic matter, especially simple carbon compounds, and typical amount N is an soil 100 milli to 1 billion in teaspoon. Action of soil decompose organic matter in mobilized nutrients, the rooting zone and rhizobium, and other genera mix nitrogen form here. Convert ammonia to nitrate and nitrate to nitrogen gases. Actinomycetes, which grow as limbs and are important in the decomposition of moderate to high pH. Uh, create a substance that help bind soil aggressively. Fungi growing fungi fungi grow in long filaments called hypa. A few micro is that miles long organic matter, especially simple carbon compounds, also living plants. Several uh, at anti-spoon amounts is available. Decomposed organic matter immobilized nutrient in the rooting zone. Microbial fungi form a naturally beneficial association with the roots. They related acid help make a phosphorus more available to plants, help stabilizer or soil agriculture. Protozoa, one-celled animals, nematodes, round worms, not segmented segmented as are earthworms. So 5 to 500 mm and 60 mm wide, 1 mm long size available. Bacteria, primarily bacteria, fungi, protozoa, the nematodes, and the yeast. Several thousand in the teaspoon, 10 to a 20 in a teaspoon amounts available in soil. Stimulates and control growth of the bacteria, release ammonia, control many disease causing organism, root triggers may cause root disease, release ammonia. Arthropods includes insects, mites, and pests, and millipedes, earthworms, microscopic to inches or more long. All the organisms several hundreds in cubic foot. Shared plant residues make it more accessible to bacteria and fungi, enhance the soil structure by a certain parrots and by boring control population of other organisms. A healthy soil is judged of trapezius, trapezius organism devouring everything is sight, including its other processing their play or food, so they are enhanced and excavating at the value of this creator to farmers' lives and cycle nutrient enhanced soil texture which improves the water and air movement, controlling disease and enhancing plant growth, nutrient cycling, one of the important sections of the soil biological community is managing nutrient soil organisms, controlling transformation nutrients among many organisms in organic forms. Organic compounds contain organic inorganic compounds do not. Plant primarily needs simple inorganic forms of each nutrient soil organism create many of these plant availability nutrients and has uh, stored nutrients in the soil as organic compounds. Decomposition is the breakdown of plant and animal residues into a different organic and inorganic compounds. Soil organism decomposition organic matter more especially under a warm moist condition than under cold or dry condition. This is why it is easier to build up soil organism matter levels in the Midwest than in the southern part of the United States, where decomposition is rapid. As per the decomposition process, many bacteria and fungi produce a humic acid in the soil. These acid family combine with each other to form large molecules of a stable for the protozoa and nematodes mineralize and activate several hundred pounds of ammonium per acre per day. Most is uh, most taken up by other soil organisms, but some is used by a plant. The reverse of mineralization is immobilization, the conversion of inorganic compounds into organic compounds. Soil organisms consume inorganic molecules and incorporate them into their cell because the immobilized solution as per are parts of a soil organism. They do not move easily through the soil and are unavailable to plants. Bacteria and fungi are responsible for a large amount of immobilization. The previous paragraph described the three kinds of the transformation performed by a natural soil organism composition, turning organic compounds into other organic compounds, mineralization, turning organic matter into inorganic compounds that may be used by plants, immobilization, turning inorganic compounds into organic compounds. Farmer depends on a bacteria for one more transformation. So mineral transformation turning inorganic matter into a other inorganic compound. Bacteria that perform mineral transformation and important in nitrogen cycling. The root of leguminous roots nitrogen fixating bacteria that cover large amount of dinitrogen from the atmosphere into form the plants can use. Some nitrogen mixing bacteria live free in our soil. Uh, Nitrification bacteria convert ammonia into nitrate. Plants prefer nitrate, but nitrate is easily leached from the soil. Some farmers apply nitrification inhibitors, which reduce the activity of nitrifying bacteria and prevent the loss of fertilizer nitrogen from the soil. Denitrifying bacteria convert nitrates into gases that are lost into the atmosphere. These species are anaerobic, so denitrification occurs only in place in the soil where there is little or no oxygen. Anaerobic conditions are more common in compacted soil and in no-till soil. Other soil bacteria are important for similar mineral transformation to sulfur, iron, and manganese. In the nutshell, soil preparation depends on its physical, chemical, and biological properties. Loam soil is covered by most of crops. The soil structure of crumbly granule is most stable for all crops. Soil test is biological agent is considered best for all dynamic activity. Soil pH near neutral 6.5 to 7.5 is suitable for almost all crops. Soil preparation depends upon crop zone, soil type, moisture content, and also purpose of crop grown. So here is completed all the some basic information about the soil nutrition, soil environment, and soil how to prepare a soil preparation. Thank you.
surface which breaks into pads of a different size and shape. Shape and size can also be observed directly from the cleavage of the pads in the soil profile. Indirect method involves a measurement of the size distribution of stable aggregates, stability of aggregates of the soil property, which is the function of soil structure. Soil is indirect method, size distribution of stable aggregates. So, dry or wet sheaving techniques are used for determination of different size stable uh, aggregates. In direct dry sheaving techniques, the proportion of a stable aggregates against a vibrating action stimulating of the scoring effect of wind is determined which the provides and the index for a characterizing the susceptibility of soil to wind erosion. In wet sheaving technique, size distribution of water stable aggregates in a determined measurement of the stability of aggregates. It is evaluated by the degree of the which soil aggregate resist dispersion. Several indicates have been developed, such as the stability index, structure coefficient, and dispersion coefficient. Stability index and is the difference between a percentage silt and clay as determined by the mechanical analysis and that the obtained by suspension of soil sample in water. The great the difference, the better in the soil structure. Structure coefficient is given by d minus s upon s, where d is a percentage of particles less than 0.25 mm in diameter as determined by the mechanical analysis, and the s is the percentage of the aggregates smaller than 0.025 mm in diameter as determined by the wet sheaving method. High the value of the structural coefficient, the better is the soil structure. Measurement of the soil properties: bulk density, infiltration rate, hydraulic conductivity, aeration, available soil water, degree of compaction of soil may be used for evaluation of soil structure. So, indicates of a soil structure amount of a different size soil aggregates is represented by the single value of the comparing the structural status of different soil or the same soil under different management particles. Among the various indicates mean a weight diameter of the aggregates is a commonly used index of soil structure. The Mean weight or diameter of aggregates gives an estimate of a weighted a percentage of the average size of all the aggregates. The proportion by weight of the given size fraction of the aggregates to the total sample weight is a multiplied by the mean diameter of the that frictions. The sum of these products for the all size frictions gives a mean weight diameter of aggregates in a mm. uh, Management of a soil structure. So the general practices for improvement of the maintenance of the soil structure, tillage operation be carried out within the range of the optimum moisture condition to ensure least destruction of the soil aggregate. Zero and minimum tillage practices be adopted to maintain adequate aeration and reduce the loss of organic matter through oxidation of or erosion. Soil surface be kept covered with the crop residues to protect aggregates from the beating action of raindrops. Check wheat emergence and add organic matter. Incorporation of the crop residues and the manures into the soil for the stabilizing aggregates. Introduction of legumes in crop rotation coupled with the application of the phosphatic fertilizer. Green manuring and cover crops are a good source of organic matter. Integrated use of organics and fertilizer for crop productions. Some soil have a specific structural problem which need a proper soil management practices for a better soil structure. Sandy soil. This soil have a problem of low water and nutrient retention. The practical method of improve structure of the soil, such as soils, is to add organic matter directly or through a green manuring. The addition of the pond sediments, can clay soil or even a compaction is helpful in increasing the proportion of small size pores for the enhancing uh, water and nutrient retention capacity. Clay soil, these soils have a restricted drainage and the aeration due to a poor aggregations. Addition of a soil matter through a helpful for improving aggregation, but the required amount is high. Therefore a crop rotation and use of phosphatic fertilizers are useful. Raised or raised bed cultivation can reduce the aeration stress problem to some extent. um, Puddlet condition in areas under prolonged waterlogging, the soil aggregations are broken, leaching to puddlet condition, poor drainage, and possible solution of a soil problem. Disparate condition, the problem of dispersion is found in a sodic soil. Addition of a gypsum is a combination with the green manuring, manures, or the incorporation of crop produce in a successful in the improving soil structure and the ameliorations of this soils. Low stability of the aggregation in the soil of the airy and semi-arid region. Due to a low organic matter content, stability of aggregates can be increased by the addition of the organic matter. Mulching may also be useful as it provides a favorable condition of the microbes to decompose organic materials. Influence of the texture and structure on the soil porosity and pore size distribution. The porosity of pore size distribution in the soil are affected by a soil factors, mainly texture and structure. The organic matter bulk density and management factor like tillage and cropping and irrigation, which affect the soil structure indirectly affect the total porosity and pore size distribution. It has already been mentioned that the porous textured soil have a low total porosity than the fine textured soil. Although the size of individual pores is large in coarser structural soil, the porosity in clay soils is a highly variable as the soils exhibit a swelling, shrinkage, and aggregation, dispersion, and compaction and cracking upon wetting and drying. The fine textured soil have a large proportion of the microbial proportion of micropores. Therefore, this soil retention higher amount of water